today was really again just going to be our work day and a day to make sure you have all of your questions answered. As you know, you do have a quiz on Monday. And that quiz is basically going to be covering homework 1 and homework 2. I don't want to say like that's it because I do know that those 2 homeworks, there was a lot of topics covered in those. If you do want more practice, then there are some options you can look. There is 2 optional handouts shared in the notes page. And then there is an old quiz posted in the answer key folder. And I would probably recommend, I think if you do the homework, then you should be fine, honestly, for the quiz. If you want to at least have one extra practice, if I were to choose which one was the most beneficial, I would probably say the old quiz because, well, I wrote the quiz and I wrote that quiz, I wrote this quiz, so they're pretty much a similar format and how they are laid out. Don't neglect that first homework with the second FTC. I know we've been spending a lot of time with homework number 2 and the first FTC stuff with the rate in and out, rate out problems and the PBA problems. But we still do have those second FTC problems as well. I was just going to kind of start today with just answering any questions that you have, and then letting you just work and then maybe ask questions more individually for the remainder of class. To keep it a little bit organized, I was going to go ahead and take questions if anyone had them on homework number 2 and kind of go over, not homework 2, I lied. I'm going to do homework 1 first. Homework number 1, and then we'll kind of switch over if anyone has any questions on homework 2. Does anyone, whether here in front of me or at home, have questions from homework 2? Yeah, Mitch.
You do number 4.
Number 4, yeah. So remember, this would just be a good review. If we need to find the derivative of an integral defined function, that is going to be the second fundamental theorem of calculus. We know that when we are doing the second fundamental theorem of calculus, we have basically the common case and the general case. If I want to find j prime, I am taking the derivative of this integral, so that is going to be one of those. I see the bottom number is just 1, but the top number is x squared. So that's going to be the general case or the common case. General, and so what does the general case state? It tells you to plug in the top number, or whatever it is, times the derivative of what you plugged in, minus plugging in the bottom, times the derivative of what you plugged in. And the derivative of 1 is just 0. So really that last term is just canceling out. So that would be j prime. That is the first derivative. This question did ask you to also find the second derivative. Well, there is no longer an integral sign there, so finding the second derivative is just going to be your regular derivative rules that we did first semester. So if I'm taking the derivative of this, what is the derivative of arctangent? The derivative of arctangent is 1 over the inside squared times the chain rule. So that would be the derivative of the inside, which is 2x. We do need to do the product rule. So that was the derivative of the first times the second plus the first times the derivative of the second. And the derivative of the second would just be 2x. So you would want to make sure you're kind of using the product rule there. And then we did have the chain rule when we took the derivative of arctangent. But what was the new stuff this semester? The new stuff in this semester, which is find j prime, which was the derivative of j using the second FTC. Yeah.
Where did the arctan after that come from?
This is the product rules. Remember, when we're doing the derivative of u times v, you have the first times the derivative of the second plus the derivative of the first times the second, or depending which order you want to do. That's what was happening there.
Is that because there's 2x?
Yeah, we had 2 x's multiplied, so we had to use the product rule. Any other questions from homework 2? Yes, Armani?
At the very bottom,
Mm-hmm.
for D of that last,
So we're looking at D. This is on the very last question. So it says for the function h defined in part C, find all the intervals in which h is decreasing. And that function h was given in C, and h is equal to the integral from x to 3. So if I'm answering this one, how do we determine when a function is decreasing? We know a function is going to be decreasing when the derivative is negative. So if I want to do this one, I first probably want to find the derivative. Well, if this was h, if I wanted to find the derivative of h, would I need to use the common case or the general case? And technically it's going to be the general because we have the x on the bottom and the number up top. So we have like plugging in the top times the derivative of what we plugged in minus plugging in the bottom times the derivative of what we plugged in. Well, that first one's just multiplied by 0, so we end up that h prime of x is equal to this negative f of x. So the idea behind this is h would be decreasing when h prime is negative. Well, h prime is the negative of f of x. So basically it's like the flip of f of x. So when I'm looking at the graph, basically for this h function, when f is above, h prime would be negative. And then when f is below, then h prime would be positive technically. So we're trying to find when h is decreasing, we're trying to find when negative f would be less than 0. Which means the same thing. F of x would be kind of greater than 0 if you think about it. And then if I wanted to look at that on the graph, oh, too far. It would be from -4 to 0 and then 0 to 3. So you think if that was negative, it would be flipped back up and then on top. Big idea apart from that question though that I really wanted to kind of focus on is that if I provided you and said like, hey, this is your h of x, that everyone should be able to figure out that that would be an expression for h prime. That's really what's important in that question. Yes, Taylor?
Would the interval be 0 to 2?
Oh, yeah, I just answered it wrong. When f is greater than 0.
Okay.
Sorry, yeah, 0 to 2, not what I said.
I
Caroline.
have a question.
Oh, yeah, go ahead.
It was on number 4.
Number 4.
Yeah. I didn't understand just how that for j double prime how x to the second got like squared on that first problem. Right,
So that
right
came
around there.
from, yeah, so that came from when we were looking at what is the derivative of arctangent. That is the rule we had first semester, and the derivative of arctangent is 1 over 1 plus the inside squared, and then you have to times it by u prime.
Oh, okay.
So that is where this part is coming from.
Right.
And I could simplify it, but didn't ask you to, so I left it like that. Any other questions for people here at home on that first homework, Carolyn?
The part C and the part D.
The part C, the one right above it, this one?
Yeah.
So this one, let h be the function given by that integral again, and we want to find all values of x for which h of x is equal to 0. So if I'm looking at this one, I'm just going to go up to the graph and redraw that one. It basically told you that h of x is equal to the integral from 3 to x of f of t. And it's asking you to find when h of x is equal to 0. Well, if h of x is equal to 0, then we basically want to find when that integral is equal to 0.
Okay, I'm confused. Why is the x move on top?
It's on top because that's how it was. Oh, because it wasn't. It was at the bottom. Cool. Helps if I actually write what it said. Try it again. Yeah. X to 3. So basically, if it's asking for when h is equal to 0, we want to find when this integral is equal to 0. So if I'm using that to answer the question, we know that an integral is equal to 0 when its area is 0, when the area kind of cancels out. I think there's an easy one. What would that bottom number have to be to automatically make the integral equal to 0? 3. We know that the integral from 3 to 3 would be 0, so that would be kind of like the obvious one. The other one, so you kind of want to like work backwards. You want to find any x value where the area would cancel out as you go up to 3. So like I can visually see there's going to be one at 1 because you have a positive triangle and a negative triangle. I know those would cancel out, so there would be a location there. And then I can kind of visually see there'll be another one at -1 because you already have like this triangle canceling with this one. And now you have this triangle canceling with that one. So you would have another one at -1.
Okay, I got confused by the -4 and 3, like the interval, but that's just the graph.
Yeah, that's just
Okay.
the graph, so you get ignored kind of that extra stuff. The main part of that one, if you're trying to find the zeros, and I will say there's definitely a question on your quiz where you have to look at a graph and identify when the integral is equal to 0.
Okay.
And I do have it on the quiz, it's not a backwards one, it is one where I have the number at the bottom and x up top. But same idea, you're looking for where the integral is equal to 0.
Okay.
Yes?
Whenever you have something like that, would the integral always just be like the negative of the function, and it's going to be 0 minus?
Yes. Any other questions on homework 1? Yes, Taylor?
Should I also do B for that one?
B on that one? Y'all really like this question. B, for the function g, so we're going to be using this one, it tells us to find the x-coordinate of each point of inflection. So we have to think, well, what do we normally use to find a point of inflection?
When it equals 0.
When what equals 0?
X.
The first derivative or the second derivative?
So,
The second derivative. So you want to kind of find it. So again, if I'm talking about b, when is the second derivative equal to 0? Well, this is the g that we're looking at. I can do the common case. So then if I did the first derivative, g prime would be equal to just f of x. So then if I want to find g double prime is basically f prime of x. And so when we're looking for a point of inflection, that's going to be where the second derivative changes signs. Maybe like g double prime goes from positive to negative or from negative to positive. So if I'm looking for where g double prime changes signs, I'm really looking for where f prime changes signs. Well, f prime would basically be the slope of this one. Where would it change signs at? It would change signs at x is equal to 1. So like if I went to just find my answer, the point of inflection would be at x is equal to 1 because, and it is because g prime of x, which is equal to f prime, changes signs. Like that's probably the initial reason you would see. What's wrong with that justification? We don't technically know what f prime looks like, so we kind of put it into terms of something we know. And I know that g prime of x, which is equal to f of x, changes direction, works. Big idea from that one, this is kind of for everyone, but kind of remembering how we can kind of write those two statements from the given ones. Like if we know that g of x is an integral, g prime is just going to be the function, g double prime is going to be f prime. I would definitely, if I was a student, review part A before your quiz tomorrow. Not tomorrow, but on Monday. Because you definitely have one like that. Any other questions on homework 1? All right, and if you think of some later, definitely ask them. How about homework 2? And let's organize it maybe a little bit. Any questions on homework 2, part A? All right, what about homework 2, part B? Yes, Lily.
Can you do B1 part D?
P1D?
Yes.
So this one is a candidate test problem. I know I put the hint there, but I know it was a candidate's test because I'm looking for a minimum. So if I was doing this one, I would go ahead and kind of create my candidate's test. we're looking at T, and then we're trying to find the minimum number of people. And then we need to remember what numbers go on our Canvas test. The easy part is going to be the X values that are the endpoints. So I know we're going to be considering 0 and 300. And I'll probably already fill in that first row too, because it tells me at 0 there's 20 people in line. And then the other values would be your critical point or critical points. How will we find them in this problem is we are going to have to rely on our calculator. So to find your critical points for a problem that is a rate in, rate out problem, the critical points will occur when the rate in is equal to the rate out. The rate in was that RFT function they gave you. The rate out was 0.7. So you basically want to graph and find the intersections of that. If you have trouble kind of setting up a window, I would let your x's go from 0 to 300, and then your y values, since that rate is 0.7, like it can be pretty small, and you'll be able to see the intersection point. I do know there's 2 intersection points. Do you want me to go over how to find them?
No.
You're good?
Yeah.
Are you do? You're good?
Oh, yeah.
Okay, so you find those intersection points. I will say I know there's 2 of them. And once you find those intersection points, then how you evaluate them, that's where the rewritten first FTC comes from. So you would have like 20 plus, that was at 0 to that first intersection point, RFT minus the 0.7 dt. That will give you a number. And then you do 20 plus the integral from 0 to b, RFT minus 0.7 dt, rate in minus rate out. And then the last one, 20 plus the integral from 0 to 300. RFT minus 0.7 dt, and then once you did all that work, you just look for the one that is the smallest.
Okay.
And it does say justify your answer, and you can literally just say like C Canvas test, and that's all you have to do. Yes, Mitch?
So 20 is the initial condition?
20 is the initial condition, yes.
The rate for out.
It's the initial condition for RFT, yeah. The rate in. Any other questions on that homework 2? Marcus, that one?
Yeah. Work D on B3.
B3D. This one, right? Yeah. Write but do not solve an equation involving an integral expression of r, the earliest time when there's no longer people in right. Okay. So we have the function of people per hour. This is R of t. I also know that people are leaving at 800 per hour. So those are kind of like my 2 equations. The initial condition is 700. And the park is closing at 8. So if I'm setting up my equation for this one, we had, I already forgot my numbers, 700 is the initial condition. So there's initially 700 people in the park. People are entering at that function R, which they open at 0 and they close 8 hours later. And then after they close, there might still some people being in line. They have to kind of finish going through the line. So the line starts processing at 0, and we're trying to find some unknown time where that rate then is equal to 0. And the rate that people were getting out of line, that was 800, right? Yeah, 800. And again, I wouldn't want to have x at the top of both those integrals because that R of t function like ceases to be a thing at 8. Like that's when they close, no one else can get in line. But once you're in line, you're going to keep processing until everyone's out of line. Any other questions on homework 2? Yeah, Mitch.
I'm a little confused on when we should use the initial condition and when we shouldn't.
The shortest way I can say it, you want to use your initial condition whenever you're talking about what's happening at a single point in time. So like, how many people are in line at t is equal to 7? How much oil has spilled out at t is equal to 3? how many people have gotten on the escalator at t is equal to 25. Those all will have the initial conditions. You're talking about some like final, definite, total amount. The ones where you don't have initial condition will be ones where you're always talking about between some intervals of time. So maybe like how much oil has leaked between 0 and 3. How many people have gotten in line from t is equal to 2 to 7. So whenever there's like a between 2 time intervals, that's just the interval will be your answer. If you're ever looking for just one instance in time, that's when you're probably going to have the initial condition in front. Any other questions you have so far?
I do.
You do, sorry. Yes, go ahead, Rachel.
Could you go over B2 Part A?
B2 Part A, yes. So this one is asking us to use a tangent line to approximate what kind of is happening with this function. This is the one with the balloon being inflated. So tangent line, good review from first semester. That's y minus y1 is equal to m times x minus x1. Filling in stuff we know. We're trying to find the tangent line at 5. So I know that the x value there would be 5. Need to find basically the point and the slope, so I want to find the y-coordinate. The y-coordinate, I believe, is coming from your initial condition. Yes. The balloon is 30 feet with a radius when t is 5, so that would be the y1. We know m is the derivative, but what is the derivative? That would be r prime. What is r prime at 5? R prime is at 2, and again, we know that r prime would be the slope. So that would be the tangent line, and if it just asks for the tangent line, then you can leave your answer like that. This one does have a secondary part to it, and it says use the tangent line to approximate the value of r of 5. To explain to you kind of why we can do that, so like we don't know what the function r looks like. The problem tells you that it's always increasing and concave up, so like r looks something like that. And what we have found is a tangent line, and we know the tangent line would be something like that. And the idea behind using the tangent line is if I don't know what the function looks like, as long as I stay close to that point of tangency, the tangent line and the graph are basically the same. Like they're close to each other, they're not exactly the same, but they're close enough to where you can estimate it. Once you get further away, they're a little bit further apart. But when they're close to a tangent line, they're pretty much the same. So we're approximating r 5.4. So I'm just going to plug it into my tangent line, 2 times 5.4 minus 5. Move that 30 over to the other side. That would be the answer. Simplify it if you want. And then it does ask to determine whether this would be over or under the actual value. And since they told us it was concave down, the only way that tangent line would appear when it's concave down is that tangent would have to be above the function. So like if it was concave up, the tangent would always be below it. So I know that this estimation on the tangent would be over the actual value because r of t is concave up. And how do I know again that was concave up? That was provided to you. Oh, it's not concave up. I'm completely lying. It's concave down. Oh, which I answered it correctly. Why can't I do math today? Concave down, and that's why it's over. Say it again.
You wrote 3 instead of 30.
Oh, cool. I just can't do anything today. 30. There we go. 2 mistakes in 1. Awesome. Question, did that make sense, Rachel?
Yes, sir.
Okay. And honestly, if this was a question on your quiz, I would probably only have find a tangent line and nothing after it. Mitch, you had a question?
I was just gonna say about 30.
My mistake, yeah. Any other questions on homework 2?
For part C.
For part C? Do you have a question on explaining what it means or using the Riemann sum?
Not like after, like B, like C, something, not from you.
Oh, part C. Okay, yeah, I got it. Any questions from part C? A lot.
C1D is
C1b. C1b actually connects to when you're trying to find an integral that's equal to 0. So 55 was the initial condition, so I knew that the velocity started at 55. How do we get to velocity? They give you a graph of acceleration, so I know that the integral of acceleration will give you velocity. 55 was the initial condition at 0, and we're trying to find a spot where when we do that acceleration, we're going to end back up at 55. So a question like this is kind of like the bug problem we did yesterday. We're basically trying to find when the area of that integral is equal to 0.
I got one answer, but then I had another answer, and the answer he said that one wasn't included in, like, at the end, when you're going from like 14 to 18, wouldn't that also give you, like, it would cancel out?
So you have to think, is will it cancel out? You have to see when you're starting at 0, would it cancel
So
out?
you have to start at.
So that's where the integral starts, like that's where the initial condition is provided. So like we have to always start here. So yeah, it's pretty easy to visually see that like at 12, it would cancel. Yes, it would cancel out if you could start at 14 and end at 18, but then you still have this region that was like subtracted in there. So it's still gonna be negative and not 0.
So you always have to start at 0.
So always start from where the initial condition is. I don't want to say always start at 0. We start at 0 because that's where the initial condition was. Let's stick with that one since you said there was a lot. Any other questions from C1? C2?
Part B,
Part B?
I think I just did something wrong, but.
Find the acceleration of the particle, and so this one's just you find A of,
Okay,
find the derivative, right?
Yeah.
So the derivative of velocity is acceleration. And you did the product rule here.
Yeah.
So this is t times sine of t squared. So I have the first times the derivative of the second. There's the chain rule.
Oh, no.
Plus,
I
oh,
see that.
missed the chain rule, or missed the t.
Yeah.
Plus, just go and finish out the derivative of the first times the second. And then you basically would find it's a calculator problem.
Yeah.
So plug in 1.5 and see if it's less than 0 or greater than 0. Or basically you're looking for is it positive, yes or no.
Yeah, that was my only issue.
Any other questions from C2?
C.
C?
I got the answer for that, but apparently it was the answer for D. So I don't.
Yeah, so let's compare C and D then. C is given y of t is a position and that y of 0 is 3, find y of 2. So this one would be the rewritten first FTC. So if you're trying to find y of 2, that would be the initial condition plus where that initial condition was, what you're trying to find. The integral velocity gives you position. Punch that into the calculator. This one is just the total distance from 0 to 2. So that is just a single integral without an initial condition, and total distance is technically the absolute value of velocity. And that's what you'd be trying to find.
Is that like basically like the F of B or whatever?
It is. There's no basically. It is. This is literally the f of b plus the f of a plus the integral from a to b of the rate. So f prime, yeah. So we know that y prime is b. So it's literally the same formula.
I did D. I set it up correctly, but.
Did you do the absolute value?
Uh-huh.
I'll come and just look in your calculator then.
Okay, well, let's redo it. I don't know how I did it, but.
Okay. I'll come look at it later. Any other questions from C2? How about C3?
C.
C. Da, 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 da. So rocket B is launched upward. I'm guessing I haven't looked at this one in a while. Rocket A is the one provided, yeah. And you want to figure out, that's the acceleration, and it has the initial height, initial velocity. Which of the two rockets is traveling faster at a time of t is equal to 80? So what values is it basically asking you to find? if you're talking about traveling faster.
Acceleration. Velocity.
Velocity is whatever, yeah, velocity. So for rocket A, its velocity at 80 is 49. So we know that one. The velocity of rocket A at 80 is 49, and that came from the table. This is the acceleration of rocket B. So for rocket B, it tells you the initial velocity is 2. And that's at t is equal to 0. So again, this will be that rewritten version of it. So for rocket B, the velocity of rocket B at 80 would be the initial condition plus the integral that occurred at 0 to 80 of that acceleration equation given to you, and then see which one's bigger. Any other questions? Yeah, Mitch.
So did you just plug in 80 into the acceleration to get the 49?
No, that came from the table. Rocket A just had the table,
Oh,
so it
okay.
just came from there. Any other questions on that last one?
Could you go over B?
B for that C? Yeah. Do you want me to talk about how doing the Riemann sum and the explaining, or just the explaining?
Both, please.
Both, okay. So it tells me, using correct units, explain the meaning of the integral from 10 to 70 v of t in terms of rocket's flight. So like doing the mid-ram, so we are going from 10 to 70. To 70, and it said 3 subintervals. So like there's 1 rectangle, there's 2 rectangles, and then there's 3 rectangles. It tells you to do an MRAM, so you're going to use the middle y value for each of them. And then for the width of them, I think they're all the same. Yeah, 20, 20, and 20. So if I wanted to find that one, let me just zoom out a little bit. The MRAM, this integral, we can evaluate with the Riemann sum. You basically have base times height plus base times height plus base times height. And I would leave my answer like that. And I do want to explain kind of the meaning of it. I think this is where it probably is the hardest part. So if I'm explaining the meaning of this, I am integrating velocity. So kind of think about what you're finding. When you integrate velocity, what is that going to become? Position. So literally this integral from 10 to 70 of v of t, that's literally the same thing as finding the position, plugging in the top number minus the bottom number. So that's going to be like y of 70 minus y of 10, which is going to be the net change in the height of the rocket. From 10 to 70, and I need some units on here. Feet seconds. Or you could even say something like the distance traveled by the rocket in feet from 10 to 70 seconds. As long as it was clear to you that you do that, like the integral of velocity is going to give you a net distance. As long as you somehow refer to the distance, starting at 10 to 70, you would be fine. Different ways to word that, but that would be kind of what it would be looking for.
For that, if you said position, would you be wrong?
Position works as well. As long as you mention that it was measured in feet, and as long as you mention that it would be from starting at 10 and ending at 70.
Would you have to say net if you said position?
You want to have to say net, and even you could just say the change in the height. Since it's always increasing, you would be fine as well if you left off the word net for that explanation. Anything else? All right. So if you do have other questions, like definitely make sure you get them answered. I hope I was able to answer the ones that you did have. I did record all of this in case you want to go back and listen to it later, in case there was something that you missed.